All right, we're going to look at factoring quadratics. Quadratic is this little guy that you see here. Let me grab a red pen real quick. Little guy you see right here, that is a quadratic, x squared plus bx plus c. We will normally see that with an a in front, but for right now our a is going to be a 1, so we don't even need to really write it. But we're almost at standard form there with x squared plus bx plus c. This is a quadratic expression. It's an expression, not an equation, because no equal sign yet. Once we throw an equal in there, then it's an equation. The c term at the back is a constant term. It's just going to be a plain number. The bx term in the middle is a linear term, and that first term that's squared is the quadratic term. Doesn't matter what letter it is. It can be any variable. Your b and your c are going to be constant numbers. B is going to be a coefficient. It's a linear term. It would graph as a line if you had it normally. C is a constant term. It's going to be just a plain number. Like in y equals mx plus b at the end, if we had y equals 2x plus 7, the 7 at the back, constant term. The 2x would be the linear term, and there's not a quadratic term. Okay, but we're going to be factoring, so let's remember what factors are. Factors are things that multiply, or that multiplied, to be what you have now. For example, if I have 12, well, what multiplied to be it? Well, 1 times 12. Everyone always forgets that one, but don't forget, 1 times itself is always the first factor. Then it's even, so 2 goes into it. 2 times 6. And let's see, 3 goes into it maybe. Let's see, 1 plus 2 is 3. 3 goes into 3, so it goes into 12. It goes 4 times. And now we've got to what I call around the horn. We've come back on itself. Like 3, the next number is 4, and that's already written down. So we're done writing factors. We don't have to keep thinking anymore. Those are definitely all finished. But those are things that multiply to be 12 factors. That's what we're talking about. And that's what we're going to do with these quadratics, with these things that look like x squared plus bx plus c. We're going to break them into things that multiply to be with them. You may remember FOIL, first, outer, inner, last. That's how we multiply two factors together to get the quadratic in the first place. Now, something I do want to remind you of, don't forget about -1 times -12, -2 times -6, -3 times -4. Those all still give you 12, positive 12, but negative numbers. People often forget those. So they're like, well, how do I get two things to add to be a negative thing? Well, they both have to be negative type deal. Okay. Now, when we look at the quadratic expression, x squared plus bx plus c, the worksheet you have has instructions on it. Worksheet 9-5 is what we're working on. But the instructions on there tell you this, but it's really in kind of old math speak. So I'm just going to make it plainer, easier, simpler to understand. Take factors of the c, right? Factors of this thing, the c, that do this sign in the middle, or in front of it, to make the middle thing with its sign. That's what we're looking for. And every time we make a factor, we're going to make a set of parentheses, and we're going to put an x in each one, because we also factor the first term. We factor the first term and the last term. But if the first one's always just that letter squared, then the factors are that letter and that letter. That's the only two things that make a squared thing, is it and itself. So each one is going to get an x. Then we have to worry about everything else, and that's factors of c. And we need the factors of c that do the sign in front of c to make the sign and the b in the middle. Okay? And that's all we're going to do every time. So let's look at a problem here. We got x squared plus 6x plus 8. This is the first example on 9-5 worksheet. Okay? So we ask the question, factors of 8, right, here and here, that add here and here to make positive 6. Those are the things that match up. So factors of 8, 1 times 8, 2 times 4, not 3, we're already back at 4. We are around the horn, okay, or we've come around the bend, whatever way you want to call it. So that's all the factors. Now which ones add to make 6? Well, 1 plus 8 is 9. And 2 plus 4 is 6, so we want the 2 and the 4. And what kind of 2 and 4? Well, we can look in the problem. We need it to be positive 6, so we need positive 2 plus positive 4. And that's all it takes. Factors the last thing that do the sign in front to make the middle. So let's look at some more examples. So factors of 21 that subtract to be positive 4. Well, 1, 21, not 2, it's not even. 3 goes 7. Not 4, not 5, not 6, and we're already back at 7 again, so when we come around the horn, we're done factoring. So we're subtracting. Well, I want to be positive. 21 minus 1 equals 20, and 7 minus 3 equals 4. That's the one I want. I want a 7 and a negative 3. Okay? And I want it to be positive 7 and a negative 3. Now you might ask yourself, well, Mr. Maggart, I got x minus 3 times x plus 7. Is that still good? Well, yes, because it's the whole thing times the whole thing. And there's something called the commutative property of multiplication. Doesn't matter what order I multiply these, I still get 21. Okay, so even this set here is a correct answer because it's x minus 3 and it's x plus 7 in both. Now what wouldn't work, what would be a no-no, is x plus 3 times x minus 7. That doesn't work because you do get negative 21 at the back when you multiply the last terms, but when you add the middle like terms, the 3x and the negative 7x is going to give you negative 4x, which is a no-no. Okay. So let's just try some more factors of 18 that add to 11. Well, 1 and 18, 2 and 9, 3 and 6, not 4 and 5, so we're around the horn. There we go. Okay, so adds to 11. Well, that'd be 2 and 9, and they both got to be positive. Factors of 4 that add to negative 5. 1 and 4, 2 and 2. 1 plus 4 is 5, so 1 and 4. Now I got to be careful here because I need negative 5, so they both need to be negative, so that I get a negative 5 and a positive 4 when I multiply them at the back. Factors of 12 that add to 13. Don't forget that 1 times itself is always a thing. So if you need 1 more than what it is, it's going to be 1 times itself. We want a 1, we want a 12. Forgot to circle my answers there. Factors of 2 that subtract to negative 1. Well, I've got 1 times 2, and that's it. I'm around the horn because they're right next to each other. So which way do they subtract to negative 1? Well, I want to take 1, I want to subtract 2. 1 minus 2 would be negative 1, so that's my positive. Factors of 10 that add to 7. 1 times 10. 2 times 5. No 3, no 4. We're back around the horn. We're good to go. So which ones add? Well, 1 and 10 is 11, 2 and 5 is 7, so I want 2 and 5, and they're both positive. And that's factoring quadratics. It's that easy. There is a pattern to what happens here. I'll show you that, okay? If there's a plus at the back of the expression, okay, like plus 8 and plus 8 here, that means you're going to have the same sign in your factors that the middle has. The middle goes with both. So in this first one, x plus 6x plus 8, the plus says they're going to get the same. They both get a plus, and then it's 2 and 4. Or x squared minus 6x plus 8, they're both going to get the same thing. They get the middle, which they both got a minus. It still makes the work. If there's a minus at the back, then they are different signs. And the middle sign goes with the largest factor. So I got a minus at the back here with x squared plus x minus 6. That means they're going to be different signs. So when I put my factors in, things that subtract, it's a negative 2 and a 3. I want 3 minus 2. So just make sure that the plus goes with the 3. It's the bigger factor because it was plus in the middle. Likewise with x squared minus x minus 6. Factors of 6 that subtract to negative 1. 2 minus 3 is going to do that, but just to double check, my minus should go with my biggest number. It's with my 3. It's good to go. And that's all there is to factoring quadratics, at least with a in the front of the x squared being a 1. And that's how we're going to attempt to do the next level where the a is not a 1. We're going to turn them into these simple ones, solve them, and then change them back.